All right, continuing on here, give the share screen. Well, with our um, with our player status, we did have scripts communicating with each other, but I want to go through this a little more carefully. Uh, Communication between game objects. So in this little scene, uh, I'm going to have uh, two objects, a player and a cube. The player is going to have a player script, and I'll have a public variable and a public game object, cube object. Either you can place the cube object into the inspector slit, slot, and remember this will show as capital Q blank object. Uh, you can drop it in there, or we can find it by name, find cube. This is going to find the cube. Uh, Here's player with cube object, and here's the cube. And it's the name and, of course, case matters. Now, once we've obtained this cube, um, we can manipulate it. So this is the player's script manipulating another object, the cube. And we do this by saying cube object dot transform and that rotate function. And this rotates about 0 about the x, 5 time delta time about the y, and 0 about the z. So this is going to work exactly as you'd expect, except now instead of us rotating the cube, instead of the cube rotating itself, our player with its script on it is the one that is manipulating this other object. Um, one note about finding an object by name: if there are more than one objects with that same name, it'll use one of them. You don't know which one of them. It's kind of random. It picks the first one that it finds. And also, a caveat with finding is that it's expensive. It's expensive because it has to look at all the objects in the world, all the objects you have in your scene, to find the one that's named name. So finding should generally not be done in functions that run frequently, like the update function. Um, if We might modify this a little bit, and uh, on the on the cube, I'll now put on the cube a little script that has its speed as an exposed variable, cube speed. So we could add to that script a function, get speed, that's going to return the cube speed. And now the player script can access the mySpeed variable cube speed by saying cube object dot get component mySpeed. That's the script on the cube, and calling its get speed function. This is similar to what we did with the get points and get health back in our game setup. The player's script is controlling the cube's behavior using a speed that is stored on the cube object. So if I run this, first of all, note in the player here, it's found the cube object, finding it by name, and the cube is spinning, and I'm not sure what will happen here if I turn this up to 100. 100. The cube runs faster. That's because the mySpeed 2 script is returning the higher value. So the cube itself can modify its own speed, and the player who's controlling the rotation of the cube will respond accordingly. Pretty cool. Now, I mentioned that finding by name is not terribly efficient. A more efficient way to find things is by tags. Uh, uh, you remember I mentioned the player tag back when we were protecting against nulls in our little game. And but we also have find game object with tag. So uh, if I tag my object here, uh, if I tag my object here, if I tag my object here, Q to that's untagged. If I tag my objects to have a tag a sphere, I can then find a cube, find the game object with tag a sphere. This is much more efficient because Unity will maintain a list of things that have particular tags, and when you go to search, you only have to look at the list of tagged things and not at everything that's in your world. There's also an analogous uh, find game objects with tag a sphere, and this returns an array of objects. So here I have an array of game objects. I've got those little square brackets after it, cubes. I'll show you what I do with this in a minute, but I have an array of scripts, the MySpeed3 script that is on the cubes. And in the start, I'm going to use find game objects with tag a sphere. That's returned into cube. So I'm finding all the objects that are tagged a sphere. Now that I have those cubes in the array cubes, I can make an array to hold references to the MySpeed scripts. So I make scripts a new MySpeed3 with number, where number is the number of objects, of cube objects that I found. And I'm going to go through that list of cube objects, individually getting each of their components my speed and storing that into the array of scripts. So now I have an array actually of scripts on different objects, and in my update function, uh, I have a float speed, which I go through the array, and I call the get speed function that in the lives in the MySpeed scripts, accessing the scripts through their array and rotating the particular cube object by that speed. And I'm using the time delta time so that it rotates at a uniform rate. Now, this means that each of these little cubes, the blue cube has a speed of 30, the green cube of minus 20, and the red cube of 10. And so each of these will rotate at different speeds. And if I want to, I can uh, crank up the speed of one of them, make it spin really fast, make it spin slower. And the player is rotating all three of these cubes. It's getting the information about how fast each cube wants to be rotated from their script and rotating them accordingly. So that's very cool. Now, having done this little trick here with the array of scripts, this is much more efficient than doing this, having a my speed that's established within the for loop, using a get component to get the speed, and then using that local my speed to call the get speed function on the script. This is expensive because it has to go out on each object and get its component. And and so this caching behavior here, where we've cached all of the scripts, all of our references to the scripts in script objects in an array, is much more efficient and saves many, many cycles. So that's something that you want to keep in mind when you're optimizing your code. I mentioned the static variables that were another way to access things. But there's also, my speed script has a static variable, public static float global speed, and somewhere in the script we're going to assign, we're going to access that in the MySpeed script, speed global, in my character's thing that sets the speed that we're going to rotate the thing. This is in number 12 here. So the player here in player script 4 um, is using MySpeed 4 speed global, and MySpeed 4 has a public variable cube speed, a public static speed global, which is assigned in the update function. And so this is going to behave just the way the others did. Our player is rotating these cubes. And if I increase this to 100, it goes faster. 1,000, it goes even faster. So this is doing it through the static variable. So there are lots of ways to communicate among scripts. Here's the scripts. Player script 4 accesses MySpeed 4 speed global. MySpeed 4 has a public static float speed global that is assigned in the update function and consequently is updated appropriately. Now, one final thing, and then I'll quit here. We saw the execute in edit mode back when I was showing you the immediate UI, GUI, the IMGUI. A script directive that lets a script execute while it's in edit mode with the game not playing. And this was useful for interactively setting up the GUI labels. Another one that's kind of cool is the add component menu. This adds an item to the pull down menus in Unity. So we can go up here in Unity and find references to our scripts. And another one that's very cool is the require component. So this one requires that a component be there on the game object that has this script. And if it doesn't, it will add it automatically, and it will not allow it to be removed. So this is pretty cool. Here's a little script, directives, that has the execute in edit mode. It has the add components MyScript directives, and it has the require component type of light. And then all it's going to do is it's going to get the component light. It knows it can do that because the required component guarantees that there will be a light there. We change its intensity and we set its color to be red. And so if I go to that scene, the directive scene here, I have an empty game object with nothing but a transform on it. Because I did that component, I now have an entry in the component menu here for different scripts. There's the directive script. This is going to add that component. It automatically added a light. Because it executes in edit mode, it's set the intensity of the light to 5 and turned its color to red. And notice I can't remove the component here. It won't let me. Can't remove component because directive depends on it. So that's pretty cool. It's a way of bulletproofing a script. If it needs a particular component, requiring it will mean that it's automatically there even if you've forgotten to add it. So that's all pretty cool. If I do want to remove this, I have to remove this script first, and then I can remove the light component. So I'm going to stop sharing there. This is our first blast through scripting. We'll have much more on scripting as we go along, as I talk about the Unity API in much more detail. I'll stop recording now. See you in class. Bye.